You go to bed at 11, like always. You close your eyes. You wait for the familiar pull, the heaviness, the slow dissolve into unconsciousness that has happened every night of your life without you ever having to think about it. It does not come. You lie there for an hour. Then 2. Your mind stays sharp, alert, fully present. Not the restless tossing of ordinary insomnia, but something different. Something has changed at a level deeper than habit or stress. Your body has stopped needing sleep entirely. You get up at 3 a.m. and you feel fine, better than fine. You feel completely, perfectly awake. This is the day you stop sleeping, forever. Let's talk about what that actually means, because the truth is far stranger and far more dangerous than simply gaining extra hours in your day. The first thing you need to understand is that sleep is not downtime. It is not a passive state your body enters because it has nothing better to do. Sleep is one of the most biologically active processes your body performs, and almost every system depends on it. Neuroscientist Matthew Walker of the University of California, Berkeley, author of Why We Sleep, has spent his career documenting what happens during the hours you are unconscious. During deep sleep, your brain activates what researchers call the glymphatic system, a network that flushes cerebrospinal fluid through brain tissue, clearing out metabolic waste products that accumulate during waking hours, including beta amyloid, the protein associated with Alzheimer's disease. This cleaning process happens almost exclusively during sleep. Without it, waste products that are normally cleared away every night would begin to accumulate continuously. Within the first 24 hours of sleep loss, this clearing process would simply stop happening, and it would never resume. The second thing that happens is more immediate. Your cognitive function begins to degrade within hours, not days. Research conducted by sleep scientist William Dement of Stanford University, who founded the world's first sleep disorders clinic, established decades ago that even modest sleep deprivation produces measurable impairment in reaction time, judgment, and emotional regulation. A study published in the journal Occupational and Environmental Medicine, led by researcher Drew Dawson, found that 17 to 19 hours without sleep produces cognitive impairment, equivalent to a blood alcohol concentration of 0.05%. At 24 hours without sleep, the impairment is comparable to a blood alcohol concentration of 0.10%, legally drunk in every jurisdiction in the world. By the time you've been awake for 36 hours, you are functioning at a level that would get you arrested for driving. But you do not get better from here. You do not adapt, because your case is not insomnia. It is something that has never been documented in a living human being who survived more than a matter of weeks. The closest real-world parallel is a condition called fatal familial insomnia, a rare genetic prion disease first documented in detail by neurologist Elio Lugaresi and colleagues at the University of Bologna in 1986. Fatal familial insomnia destroys the thalamus, the brain region responsible for regulating sleep, through a progressive accumulation of misfolded prion proteins. Patients with this condition experience a relentless, irreversible loss of the ability to sleep, progressing through stages of worsening insomnia, panic attacks, paranoia, hallucinations, rapid weight loss, dementia, and ultimately death, typically within 18 months of symptom onset. Sleep researcher Dr. Pasquale Montagna, who studied the condition extensively, documented that the disease does not simply remove sleep. It removes the boundary between sleep and wakefulness entirely. Patients enter a state researchers call status oneiricus, a waking dream state in which fragments of dream content intrude into conscious awareness while the patient is ostensibly awake, producing a kind of permanent, undifferentiated hallucinatory consciousness that is neither fully asleep nor fully awake. If this is what happens to you, if your sleep loss is total and permanent in the way fatal familial insomnia models, the timeline would unfold something like this. In the first week, you would experience persistent fatigue that does not respond to rest, because rest without sleep does not restore the brain. You would notice your reaction time slowing, your emotional regulation deteriorating, small irritations triggering disproportionate responses. Your immune system would begin to weaken. Research by sleep immunologist Eve Van Cauter of the University of Chicago has demonstrated that even partial sleep restriction significantly suppresses immune function, reducing antibody response and increasing inflammatory markers throughout the body. By the second week, the psychiatric symptoms would begin. Sustained sleep deprivation produces a state that closely resembles psychosis. Research published by psychiatrist David Dinges of the University of Pennsylvania, who has studied extended wakefulness extensively, documented that subjects deprived of sleep for extended periods begin to experience visual and auditory hallucinations, paranoid ideation, and what researchers call microsleeps, brief, uncontrollable episodes of unconsciousness lasting seconds, during which the brain essentially forces a fragment of the sleep it is being denied, regardless of what the person is doing at the time. A person experiencing microsleeps while driving, operating machinery, or crossing a street would have no warning and no control. By the third week, the physical deterioration would accelerate. The body's ability to regulate temperature would begin to fail. Body temperature regulation is partly governed by circadian and sleep-dependent processes, and the breakdown of those processes produces dangerous instability. Wound healing, which depends heavily on growth hormone released primarily during deep sleep, would slow dramatically. Glucose metabolism would become severely impaired. A landmark study, led by researcher Eve Van Cauter, found that even 6 nights of partial sleep restriction produced glucose tolerance and insulin sensitivity comparable to early-stage diabetes in healthy young subjects. Total, permanent sleep loss would push these metabolic systems toward catastrophic failure. By the 4th to 6th week, based on the documented progression of fatal familial insomnia patients, profound dementia-like cognitive decline would set in. The hallucinations would become continuous rather than episodic. The boundary between dream and waking reality, which depends on neurological processes that require sleep cycles to maintain, would collapse entirely. You would exist in a state that researchers studying the condition have described as a permanent confusional state. Aware, in some sense, but unable to reliably distinguish internal mental content from external reality. In documented cases of fatal familial insomnia, death typically occurs between 7 and 36 months after symptom onset, with most patients succumbing to complications including pneumonia, cardiac failure, or the cumulative effects of profound physiological exhaustion, rather than the sleeplessness itself directly causing death. The body's systems, deprived of the restorative processes that sleep provides, simply begin to fail in cascading sequence. This is the grim biological reality of what total permanent sleep loss would actually do to a human being. But here is where your situation becomes scientifically uncharted territory, because everything we know about sleep loss comes from people whose brains were also damaged or diseased in ways that caused the insomnia in the first place. Fatal familial insomnia patients are not simply not sleeping. Their thalamus is actively deteriorating. The neurological damage that prevents sleep is the same damage causing the broader cognitive collapse. What if your sleep loss were not caused by neurological damage? What if your brain remained otherwise completely healthy, simply no longer requiring sleep? This is not entirely science fiction. Researchers studying rare genetic mutations have identified a small number of people with a condition informally called natural short sleep, linked to mutations in genes including DEC2 and ADRB1, studied extensively by neuroscientist Ying-Hui Fu at the University of California, San Francisco. People with these mutations sleep just 4 to 6 hours per night and experience no negative health effects. Their brains appear to extract the same restorative benefits from a compressed sleep window that most people require 7 to 9 hours to achieve. Fu's research suggests that the relationship between sleep duration and sleep function might be more flexible than previously understood. That it may be possible, in rare genetic cases, to achieve the necessary biological functions of sleep more efficiently. But Fu has been careful to note that no documented case, genetic or otherwise, eliminates the need for sleep entirely. Every known human being requires some sleep. There is no human on record who has gone without sleep entirely and survived in good health. If your transformation genuinely allowed your body to perform the restorative functions of sleep, clearing metabolic waste, consolidating memory, regulating hormones, repairing tissue, through some entirely novel mechanism while you remained conscious, you would be biologically unprecedented. You would also gain something almost no human in history has ever had: roughly 1/3 more conscious hours in every day across an entire lifetime. Neuroscientist Russell Foster of Oxford University, who studies circadian rhythms, has calculated that the average person spends approximately 26 years of a normal lifespan asleep. If you eliminated that requirement while somehow preserving its restorative function, you would functionally extend your conscious life by decades. What would you do with an extra 8 hours every single day? Psychologist Anders Ericsson of Florida State University, whose research on deliberate practice established what later became popularized as the 10,000-hour rule, found that expertise develops through sustained, focused practice over extended periods. An extra 8 hours daily would allow for a doubling of the deliberate practice available to master any skill across a lifetime. But there is a deeper question beneath the practical one. Philosopher Bernard Williams, in considering what makes a human life meaningful, argued that the texture of human existence, its rhythms of effort and rest, waking and dreaming, presence and absence, is part of what gives life its shape and meaning. Sleep is not simply lost time. It is a third of the architecture of being human, the place where memories consolidate into permanent form, where emotional experiences are processed and integrated, where the unconscious mind, through dreaming, appears to work through problems and experiences the conscious mind has not resolved. Psychologist and dream researcher Rosalind Cartwright of Rush University Medical Center documented decades of evidence that dreaming plays a measurable role in emotional processing. That people who are prevented from entering REM sleep, even while still getting adequate total sleep, show impaired ability to process emotionally difficult experiences. The unconscious processing that happens during sleep is not incidental to human psychology. It may be foundational to it. If you never sleep again and never dream again, what happens to that processing? You would remain conscious through every moment of grief, every unresolved conflict, every difficult emotional experience, with no nightly interval in which your unconscious mind works through what your conscious mind cannot yet face. You would carry the full weight of every day forward into the next, without the partial reset that sleep provides. Over months and years, this absence might prove far more psychologically significant than the simple gain of extra hours. So here's the real question this transformation poses. Sleep evolved across hundreds of millions of years, present in some form in nearly every studied animal species, including organisms with nervous systems far simpler than your own. Its persistence across such a vast span of evolutionary time, despite the obvious vulnerability it creates. Every sleeping animal is exposed to predators, unable to respond to danger, suggests that whatever sleep does for the brain and body is valuable enough to be worth that profound risk, repeated every single day for every creature that does it. If you could remove sleep and keep everything else intact, you would be removing something evolution has never found a way to eliminate, despite enormous pressure to do so. That is not proof it is essential. But it is, at minimum, a signal worth taking seriously. You are still awake. It is past midnight. Tomorrow, you will have 16 extra waking hours that no other version of you has ever had. The question is not whether you can survive without sleeping. The question is what kind of life you are building in all that extra time. And what you are quietly losing every single night that you no longer have the chance to get back.